Okay, welcome back everybody for our final section, population in 2024 and beyond. Awesome. So we will start as we often do with a thought experiment here. So you can imagine, all right, we have some society, right? 500 men, 500 women, right? We're just going to imagine that there is a perfect 50-50 sex ratio, even though this is never the case. Each woman, on average, has 3 children, right? So what's going to happen to the population over time, right? Now, we assume, as is traditionally done for studies like this, right, that we have these sort of family units, right? We have one man, one woman, some number of children, right, in every single case, just for the sake of simplicity and how this was traditionally done. 3 children on average per woman. What's going to happen to the population? Well, after one generation, right, each couple, pair of 2, is going to have 3 children, right? And, 50-50, so on average 1.5 would be women, right? Which is going to become 4.5, which is going to, increase exponentially, right? Exponential growth of population is what would happen if this were the case. We notice, right, this exponential curve is exactly what we see in the long run, and broadly speaking, historically, this is about what has happened. Same exact thing, right? Except now, instead of 3 children on average, it's 2. Okay, so we start off with 500 and 500, right? And then each couple, pair of 2, has 2 children who will go on to have 2 children, who will go on to have 2 children, right? Okay. The total population is going to stay exactly the same over time, right? It's going to be no rate of change, just a total flat line. Now, does this actually happen? Can this actually exist in reality? No, absolutely not. There is no such thing as a perfectly flat population curve 0 growth scenario, and we should not want a perfectly flat population curve, right? We want something that is at least going up and down a little bit. Is far better than something that looks like this, which comes before, this. Okay. 500 men, 500 women, right? Each woman has 1 child on average, right? So we start off, okay, we have a couple who has 1 child, right? Has to go out and find someone else, right, to become a couple who has 1 child. Okay. Population is going to go down over time, right? So this is exponential decay of curve. So it's going to fall very quickly at first, and then start to fall slowly, falling slowly, right, over time until, well, if this was the rate, then eventually they would go extinct, right? This is not sustainable. This leads into our first topic, right, that we need to talk about, which is fertility, right? The number of births per woman of children who survive into adulthood. That is how this is defined. And we could just kind of check our bearings with this with a thought experiment and also sort of reinforce some of what we've been talking about. So it's 1870, right? Things are beginning to change quickly, right? It is post-Civil War era. You look at some city in America, right? Pick whichever your favorite city is, right? You go into that city and you try to figure out the ratio of how many children who survive past the age of 5 per woman, right? On average. And, is it 2, right? We talked about replacement levels, right? If it's 2, then the population is going to stay the same over time. Is it 3 kids per woman? 4? So the actual answer, right, is even higher than any of those. And to be clear, this is not like the number of, children per family or anything like that. This is the number of kids per woman, like overall, right? Not just looking at people who are couples, right? And this was even higher before, right? As high in the United States as like 7, right? But notice what has happened to this over time, right? This is largely driven by improvements in medicine, education, technology, nutrition, right? Better ways of combating infectious disease means that people no longer have as many kids as possible, right? Because they can be pretty damn sure that those kids are going to survive into adulthood, or at least a lot more sure than they used to be. People decide on their own to have fewer children as a result. Notice the giant dip during the war era, right? From 1919 for World War I all the way up through World War II, and then this thing we have hopefully heard of called the baby boom afterward, which bucks the trend, for lack of a better way to put it, right? And slowly declining up until about where it is today. Now, for reasons of immigration, the U.S. population is still expanding, even though if we don't consider immigration, fertility-wise, right, we are below what is considered the replacement level, which is about 2.1, all things considered. So what factors influence population growth? The two that we're really going to be focused on are fertility on the one hand and life expectancy or death rate, mortality, which are interconnected factors on the other end, right? Fertility and death rate. And for this idea of life expectancy, right, to go to the other factors. So not just how many children, right, but how long we expect them to live, right? We mentioned earlier on that this was something like in the 30s historically, right, all the way up to the global now average life expectancy, whole entire planet, which is something like 74, and even higher in wealthy, more developed countries, right? So now we can revisit these graphs once again with a little bit more context in mind, seeing them a little bit differently, right? Child mortality in 1800, extremely high, at least 30 to 40%, could be higher. It's really hard to get an exact figure on something that is so long ago and so difficult to piece out on the scale of the entire globe. 1950, right, we're in the post-war era, so baby boom era, something like 4 or 5%, right? So 1 in every 25 children, 1 in every 20 children would die before their 5th birthday. Still extremely high in much of the developing world, but significantly better compared to 1800 in much of the wealthier developed world, North America, the so-called global West, Europe, Australia, all the way to today, right? We notice that infant mortality is very low. Part of the reason why population is still going up through most of the world. So those two factors in combination, right? Life expectancy and fertility are going to be our key for population growth, right? So we looked at infant mortality, now we look at life expectancy here, right? Something like 30 years historically as a rough estimate. Post-war, something like 70 years. And keep in mind, right, this isn't saying that a person who is 35 years old would be considered like, you know, an old man or whatever. This was an average. So people who did survive childhood could be expected to live a lot longer, just to kind of get that misconception out of the way. Life expectancy in 1950 we see is horribly unequal, just like with infant mortality. Most of the developed world is at least approaching where it is today. Advancements in nutrition, medicine, education, okay. All the way up to where it is now. So most of the developed world, we're in like, 77 plus, even in countries which are not the wealthiest, not the most advanced. You notice there's only a 2-year life expectancy difference between the wealthiest nation on earth, the United States, and Mexico, which is a stage 2 country, as we'll talk about, industrialized, but not fully developed the way that the United States or Western Europe is, all right? Notice, right, just like with infant mortality, even in parts of the world which are most impoverished, struggling, right, it's still way higher than it was before. Still way better to be born now. So now we can start to see why this population would be going up exponentially through these years, right, as life expectancy goes way up, infant mortality goes way down. But as fertility starts to fall with a kind of delay, right, so life expectancy goes up first, infant mortality goes up first. Then fertility starts to go down as people understand that they no longer need to have as many children as possible. They can expect them to live into adulthood, right? Those two factors and the interplay of them are what explain these curves, why they go up exponentially, why they start to eventually level off and then decline. Life expectancy in the United States, just to give an example, has looked something like this, right? So we notice there's a bit of a mess to it, but broadly speaking, overall upward until it gets to something like 77, 78, where it is today. There's two important things we want to point out here, right? First, you notice this huge drop in life expectancy. 1920 era, is it due to the war? No. It's due to pandemic, right? The so-called Spanish flu, influenza, virus pandemic, which came right after World War I, right? These things. Terrible disease, right? There was a big pandemic about 100 years before COVID on the dot. Other thing, right? We notice that life expectancy declines in 2020. What's the reason? Is infectious disease, once again. COVID and related issues being the first thing to disrupt this overall trend in life expectancy in like 100 years, right? Serious issue. putting it all together, we can talk about stages of development for different countries around the world, right? From, developing or undeveloped, right, so-called pre-industrial, to industrial countries, to mature industrial, post-industrial, right, where the United States is, and then whatever stage comes next, right? Just to put this one more time into a visual form, right? So we've got our birth rate in pink, our death rate, right, in blue, right? And these are our 4 stages, right? Pre-industrial, industrial, mature industrial, and post-industrial, and then beyond, where nobody knows. Notice, right? Death rate starts to fall, right, as countries enter the more developed stage. Death rate begins to fall first. Population goes way up because children are surviving into adulthood. Birth rate starts to decline later on, right? As people decide to have fewer children, have access to birth control, resources, medicine, education, all the reasons why that begins to decline. Death rate, right, declines, but hits a certain point where it becomes much harder to improve life expectancy, right? Birth rate starts to hit about what is replacement level, about 2.1, depending, right? These start to level off once again, and then, projecting into the future, what we're mostly seeing around the world, population levels off or even starts to decline. Death rate holds steady but maybe slightly improves, right? But birth rate continues to fall for a number of complicated reasons. One more different way of seeing it, right? So these are our 5 stages of development, all the way from pre-industrial to post-industrial, right? The death rate begins to fall first, which leads to a giant increase in population over time. Birth rate lags after, but then begins to fall. They both reach stable levels, and then the population starts to decline in a lot of cases. For now, we're not going to worry about these population pyramids, but this does a fantastic job of summing the whole story up. As far as putting, some phases to the names here, right, different countries. Pre-industrial, we talked about Ethiopia would be a good country to have in mind for a pre-industrial country whose population is still rapidly going up, right? Second stage would be Afghanistan, right? For a country which has industrialized, it is not completely the way there yet, right? But is starting to see significant improvements in terms of development, economy, way of life. Mature industrial, we might picture Mexico as being in stage 3, right? Still increasing in population, but starting to level off. Birth rate has been high for a long time, but is starting to decline. Post-industrial and beyond, right? You might look at countries like South Korea or Japan. We're starting to run into the opposite problem of what Malthus was talking about, right? These countries are having really serious issues because their population is on the decline. So I believe the fertility rate for South Korea, right? We talked about how it has to be at least 2 in order to sustain the population. Their fertility rate is something like 0.7, like 1/3 as many new babies being born as it would take to keep the population stable. In other words, they have a big boom of elderly population who cannot work relative to how many people are entering the workforce and getting jobs and making money and being able to support those elderly citizens, right? It's causing massive issues. Now, the reasons for this are complicated. There is a really strict work culture. There is a decline in marriage rates for all sorts of cultural and economic reasons. Childcare is hugely expensive. The government there has tried to fight this and has been completely unsuccessful. Efforts from the government, from the top down, to do anything about this have not worked. With that, we can move into our big question, right? So where are all the people? Where is human population concentrated and why? What are the factors that influence that? Climate, precipitation, biodiversity, which relates to food production, comfortable climate, good social bonds. Do people live close together or further apart, and what is driving that, right? Manufacturing, development of the Industrial Revolution, people concentrate into cities because of the money, right? It's the economy, stupid. That's where the jobs are. That is why people move there. Consequences of urbanization and driving factors as well as the consequences, right? Development of slums and informal settlements, what they have, what they don't have, and why, and conflicts related to that. Views of population, the way this has changed over time, right? What was Malthus's argument? What are the problems with it? What are the consequences? We are human beings first and scientists second, always. So we can consider it in both ways and figure out it is wrong in both ways. Finally, where is their growth and what factors contribute to that over time in these different areas of the world?